Good evening, everybody. My name is Amit Matety. I'm a principal software engineer at Intuit. This is my colleague.
Hi, I'm Ben Covi. I'm a staff engineer on the same team.
Ben and I are going to basically be sharing our AWS Journey for the data platform. We're basically going to be talking through kind of how we went about this major pivot. We're also going to be talking about a security strategy that was involved and operations in AWS. You're basically going to get an account of how a couple of software engineers take on security is. Primarily, we are not security professionals, but how do we kind of adopt security in our day-to-day software engineering operations? So how many of you here have actually used or heard of TurboTax, Mint, QuickBooks? Awesome, you're using some awesome products. So Intuit is the company that actually builds these awesome products and basically deliver financial management as well as compliance products and services for individuals, businesses, self-employed professionals as well as accounting professionals in the United States, Canada, and internationally. We were founded in 1983 and are headquartered in Mountain View, California, right next to Googleplex. So our customers basically entrust us with a lot of sensitive data. And to make sure that we take care of our customers' data, we have very clearly defined data stewardship principles, data handling guidelines to make sure that that data stays safe and secure and does not fall into the wrong hands. We're going to talk a little bit about our data handling principles during this presentation. So what is Intuit Data Platform? Intuit Data Platform is a multi-tenant platform for storing customers' data. We support basically both key value as well as document store use cases. We are a managed service that out of the box provides to our clients things like access control, encryption, auditing, data lifecycle management, multimodal integrations. What I mean by that is basically, all our clients have different access patterns. So maybe NoSQL works for you, search works for you, graph works for you. We basically take care of kind of moving the data behind the scenes so that you have different query patterns that you can leverage. We have analytics integration. We have a big team in data platform, which is basically does data lake and stuff along those lines. So we have integrations there where you can kind of get access to data in a streaming mode. Or you want to kind of do some kind of analytics on the data or kind of machine learning and all that stuff. So we provide all those integrations internally. Who are our clients? So we are basically an internal facing service. So our clients are basically primarily TurboTax ecosystem and other critical experiences within Intuit. So we are kind of lower in the stack. We have a lot of business services that are built on the top of us that basically drive the experiences like Mint, TurboTax, and stuff. We, during tax season, we are kind of built to support around 100,000 TPS. That's what we are tested for, and that keeps growing. We basically have petabytes of data that we store in AWS as part of our move to AWS. And during a tax season, we easily support kind of billions of requests through the 3-4 months primary tax season. So this is kind of a very high-level logical architecture of Intuit Data Platform. So we are basically active in 2 regions. We don't really have the concept of like a kind of a cold standby or hot standby. We basically expose all our services to our business services using REST APIs. So we have an application server layer. And behind the scenes, we have key value stores and document stores, which basically provide the functionality that are required by the business units within Intuit. And something that's not shown in this diagram is basically the integrations to the lake, kind of the streaming integrations and stuff that we basically have built into the platform. So replication is something that we provide out of the box. We take care of the HA and DR strategy and everything else. So our clients basically can focus on kind of providing their awesome experiences to our clients or end users and not have to worry about kind of managing the data and kind of handling the data and all the fun stuff that comes with data. So now that you know who we are, what we do, and who our clients are, basically we're going to dive into the AWS Journey here. So with any journey, right, you need a compass. You need some principles that help you drive and make sure you're making the right decisions. So these were our guiding principles. If you look at these principles, basically things like highly available and secure, never lose data, right? You won't really work with a platform that kind of loses data or is not secure. So these are things that I think should not come as a surprise to anybody. Keep it simple, right? We as engineers have a tendency to over-engineer stuff. Let's not kid ourselves. So basically, that's something that we have to make sure, it's in our face to make sure that we keep it simple and we design with that strategy in place. Leveraging existing patterns. It might be our first journey into AWS, but it's not that folks have not done this before. It might not be exactly what we are doing, but it's important that we learn from what other folks have done. So that was something that's critical for us. Don't reinvent the wheel. Refactor to accelerate, right? You're used to using certain technologies and other stuff in your data center. The idea is, okay, which of this is basically something that you can refactor after you get there? So basically the concept of a two-way door versus a one-way door. Can I go to the cloud and then refactor it? Or going to the cloud will make it difficult to refactor this. So that was another part of it. And then automate everything, right? Something that we take for granted, but I think that's very important for us to know that, in the cloud, automate everything so you can really stamp out exactly the same infrastructure or, experiences everywhere. And for some of you might be thinking, right, this is not really kind of just security related. This is just kind of in general, right? Security is pervasive. So all of these principles apply to anything, just not security as well. So that's something that we need to keep in mind. The next part is basically, right, in computer science, if you're given a big problem to solve, you just don't go and jump on the problem and try solving it, right? The best way to solve any problem, as most of us already know, is to decompose the problem, break the problem up. It's much easier to solve the problem when it's in smaller chunks, addressable. That's exactly what we did as part of our journey. We tried to break up the problem, and then we came up with what we called big boulders. These are the things that either are complex to solve or are time-consuming, right? And these are the things that we wanted to basically address heads-on so that it makes our journey quicker, and basically over time, things become faster and easier to kind of operate. So technology evaluation was one big part. Then is the security strategy. Porting the application, what changes as you basically make decisions on technology or your security strategy? How does your operations change in the cloud? HADR strategy, right? How does your FMEA and all the other stuff need to change in the cloud? And then finally, being a data platform team, we have a lot of data that we had in our data centers. So the idea is like, how do you kind of move this data securely to the cloud? Make sure that the journey that we were going was basically not just move directly to the cloud. We had a hybrid cloud for a bit, and then we finally actually moved to AWS completely. So how do we kind of operate in that environment? As part of this session, we're basically going to be focusing on the technology evaluation, security strategy, and operations primarily. But if you have questions or anything else just about our journey in general, Ben and I are more than happy to answer your questions after the session. But the focus would be on these three topics. So on the technology evaluation part, right, there are like 4 major buckets. So there was the application server hosting, key value store, document store, and encryption provider. So for application server hosting, in our data centers, we are primarily using VMs. Most of the folks do that. And we decided to do a lift and shift. And the most equivalent technology in the cloud was basically EC2. We did kind of consider, okay, what if we did EKS, we did like serverless, right? Everything is really cool, but the thing was our primary focus was to make sure, based on the guiding principles, that we have to get to the cloud first. All of these were things that we could always refactor when we got to the cloud. And also making some of these changes adds a lot of other overhead like operations and other things that we might not think of. On the key value store, we were using Cassandra on bare metals in our data centers. And as part of the AWS journey, like I mentioned, we are kind of going through a hybrid cloud journey. So we wanted to make sure that we couldn't just kind of pivot to using Dynamo right off the gates or any other such technology. So we decided to go with Cassandra as part of the journey. So we decided to go with Cassandra on Amazon EC2 with EBS volumes. And then on the document store side, in our data centers, we were using IBM CleverSafe. And a combination of some aspects were using S3 as well, but the primary was IBM CleverSafe. But in AWS, we decided that this was a good time for us to basically pay down the tech debt of having multiple different document stores and just kind of go with S3, just so that it'll accelerate our journey. And then finally, the encryption provider. So we were using a product called SafeNet from Gemalto. And Intuit basically had bought a security company, which we now call Intuit Data Protection Service. It's basically a managed service, just like Intuit Data Platform for the kind of services within Intuit. So it was a standard that we have at Intuit that all new services going to AWS or any new services coming up have to basically adopt to Intuit Data Protection Service. We'll talk a little bit more about this service in one of the slides that's coming up. But we basically decided to use Intuit Data Protection Services with KMS as a combination to kind of solve for our needs. So I'm not sure how many of you have actually looked at this diagram by AWS. It's a pretty neat responsibility sharing of how to kind of address security in the cloud. So at the bottom there, we have basically AWS that is responsible for security of the cloud, so the infrastructure, right? The compute, storage, database, regions, AZs, and all that stuff. And the customer is basically responsible for the data, responsible for kind of making sure using the right IAM roles, right? Your network is configured well, your ACLs, NACLs, and all that stuff, making sure that you're kind of patching your OS. So there is a clear share of responsibilities here, basically, that this diagram shows. So taking this into play, what we did was basically we came up with a security strategy at a high level. These are the big buckets that we have. So infrastructure, right? First, you have to figure out how you're going to deploy, what with all the technologies that you've decided on. How do you then want to handle your data? How do you want to partition? How do you want to take account of access, right? Basically accessing your resources. And then finally, things that security strategy kind of comes with, right? Risk analysis as well as testing your efforts. So I'm going to hand it over to Ben, who's going to talk about the infrastructure.
Yeah, great. Give me something to do with my hands. I like this. Okay, so I'm going to cover some of the technical details at a high level of the infrastructure. When Intuit jumped into AWS with both feet, unfortunately, they didn't just write out blank checks and say, go for it. There is some structure imposed. There's a central team at Intuit that we call Cloud Operations that provisions much of the initial account, which is the basis then for our infrastructure, over which we overlay a bunch more infrastructure. They deploy accounts, VPCs, subnets for everyone at the company. And it's a solid set of patterns stamped out as a CloudFormation stack, the same way thousands of times. It's nice to have central authority at the top coordinating efforts across the company. They've got a few really big CIDR ranges, for instance, and they'll tear off a little chunk every time somebody requests a new VPC. You would normally not have to worry about conflicts in your CIDR ranges when you're talking about private IPs, but at a company the size of Intuit, you will eventually accumulate enough routes to via VPC peering and transit gateways to other services elsewhere at the company that you will inevitably conflict with someone. So again, it's nice to have the coordination handled at a higher level. So most of what you see in this diagram comes from that initial deployment, the initial CloudFormation stack. The first thing to note here is that the 3 vertical slices, and those represent availability zones. Everything Intuit-wide is across 3 availability zones for high availability purposes, and so accordingly, everything else we do comes in triplicate. Starting with the subnets. The horizontal rows here represent 4 classes of subnet: ingress, egress, private, and data. And there's 3 of each, so a total of 12. The ingress subnets are public. They're intended for load balancers and elastic IPs. Private is your application tier. Data is your backend data store tier. And segregating the subnets by their intended use this way allows for more restrictive access controls in a granular way. For instance, from your application tier, you might need to open a private link to another service in another account, or just hit an HTTP endpoint somewhere. You can do that in the application tier, but the data tier, where you've got your data store, is locked off. There's no routes out of the VPC. There are two other major things on the diagram to point out that we get from cloud operations. One is the S3 VPC endpoint. Every one of our subnet routing tables includes a route to this, and that way we avoid sending any S3 traffic over the public internet. Of everything you want to keep in-house, your actual data is probably the main one. And the last thing that we get from CloudOps is a set of NAT gateways. There's one situated in each of the egress subnets. So from within the VPC, all outbound traffic is routed to one of those NAT gateways. And then there's a network ACL associated with the egress subnets, which puts tight controls on outbound traffic ports. So that's where all egress is controlled. So that's 90% of the diagram. The other 10% is us. We work hard to adhere to best practices and typical cloud patterns. We control ingress for our operators with bastion hosts. We do blue-green deployments of our application in the private subnets using autoscaling groups attached to application load balancers in the ingress subnets, security groups on all of the above that reject traffic coming from outside the Intuit network, and access logging is enabled everywhere. The data store tier consists of S3 for blob storage, Cassandra for metadata. We have Cassandra rings deployed in the data subnets, and there are security groups there allowing interconnectivity within the VPC, but also across a VPC peering connection to an account in another region. Everything is duplicated in that other account for both high availability and disaster recovery purposes. So the two Cassandra rings are parallel, and they replicate back and forth across this one security group rule that lets them do it. Every Cassandra node is in an autoscaling group of size 1. So if we need to restack, or if there's an outage, some sort of a termination based on an EC2 problem, the new node will come up. It will use EC2 tagging to locate the old node's EBS volume and elastic IP, and it will rejoin the ring transparently with very little downtime. And finally, we define a number of CNAME records in Route 53 with a simple failover routing policy, which will send traffic either to something in this VPC, an endpoint in this VPC, or to one over in that DR account I mentioned a minute ago, based on uptime. And Intuit has an internal service gateway that handles both user authentication and route-based authorization for specific routes, and they will feed traffic to us after it's already been authenticated. And we simply receive ticketed requests in one of our accounts through these Route 53 records. So with infrastructure out of the way, I'll hand it back over to Amit.
Thanks, Ben. I know there's a lot of information basically in those slides. If you have any questions, definitely we can answer it after the session. So like Ben mentioned, we have the data subnet pretty locked down, but there is the other aspect is how do you handle your data? So one of the most important things that we do as Intuit as part of like the data handling, data stewardship principles is we have clear data classifications for any data that our clients store with us. So basically classify your data as public, restricted, sensitive, highly sensitive, and secret, which drives a lot of the platform functionality on behalf of the client so they don't have to worry about kind of how to handle the data. So once you have the what data and how is the data classified and what you're going to encrypt, the next question comes in is how do you want to go ahead and encrypt this data, right? So you have ALE, which is the application level encryption that we all know of, and then we have the encryption at rest. We at Intuit basically kind of use both these strategies to our advantage. So we use application level encryption for sensitive data and above, and we make sure that we basically kind of are using our Intuit data protection service that I'm going to talk about coming up in the next slide about how we use it. And then we basically use symmetric key encryption, AES-256, probabilistic algorithm, make sure the data is secured and encrypted. And then that's not the end of it, right? The idea is, okay, you can encrypt the data, which pretty much like everyone does it by default. I think it's a no-brainer. The idea is also make sure you use the right best practices. You want to make sure that your encryption key or your cryptographic key that you're using is also being rotated on a frequent basis, right? You want to kind of just keep moving the needle. And also make sure that you're kind of adhering to the life cycle of a cryptographic key. So when you rotate your key, make sure you have new data that's basically kind of getting encrypted with a new key. You also make sure that eventually your old key is no longer being used, so you have to go back and re-encrypt your old data. So you can kind of make sure that your old key is only used for reads, and then finally it's basically deprecated and it's no longer available. So you're basically kind of moving the needle so it doesn't fall into the wrong hands. And the second part is encryption at rest. We encrypt all our data at rest, period. There's no two ways about it. So we use AWS KMS for it, and we have the right kind of policies in place to make sure the right folks can kind of access the data. I've talked a lot about Intuit Data Protection Services. So what is Intuit Data Protection Service? It's basically Intuit's key management and HSM solution, so it's kind of close to what KMS provides. But it's basically a managed solution for all Intuit services, and it provides like generating and securing cryptographic keys, application secrets. It's integrated into our CI/CD process, so when we deploy and we have to deploy secrets and everything else, all of that is kind of very tightly integrated. It provides encryption, decryption algorithms, both symmetric, asymmetric, key versioning, key rotation, and the best part of it is it feels very similar to an AWS service for us because it's a managed service. The access control is all policy based. For folks who we worked in AWS, right, kind of policies around who can get access from which region, from which VPC, which subnet, even which IP, role, and even all the down to which AMI you're running. Basically, we can kind of control all that stuff. So it basically kind of makes it very easy for us to kind of figure out who can do what operations on the cryptographic keys. So it's kind of, and like I initially mentioned, it functions both in our data center as well as in the cloud. So basically, it provides us the functionality in both the places. So it's kind of the same.
Where is it hosted? Is it actually?
Can I take the questions at the end, if you don't mind? Thank you. The security strategy, the next part is basically the partitioning part of it, right? So the thing is, you don't want all your data to be in the same place. Again, like we mentioned, it's a platform for multiple BUs, multiple functional groups. So we basically partition our data, which we call swim lanes, and we basically kind of have different key value stores, different document stores, so multiple tables, S3 buckets, and combine this with all the different cryptographic keys and kind of accounts and all that. So there's basically security in depth concept that we bring in here to make sure that we can kind of, not just from security perspective, but from an operational perspective, also be able to kind of manage our customers' data. So we've kind of got the infrastructure, we've got the data handling, we've got the partitioning and all that taken care of. But access is another big thing, right? So there are two buckets under which this falls. One is the platform runtime. What does a platform need to access resources to be able to do its functionality? And the second is the platform operations. So the operations is basically the day-to-day operating, debugging, and any other stuff that the engineers need to perform. So on the runtime aspect, we basically clearly mandated that we will not have any kind of access and secret keys, period. Like that's kind of a strict red flag. There are policies and alerting in place to monitor that. We want only usage of instance profile roles so that we can tie down everything based on kind of all the different policy goodies that AWS provides, like regions, services, roles, VPCs, operations and stuff. So it's the least privilege that the platform runtime needs to do its operation. On the platform operations side, we use a tool called Olympus, which is basically AWS access management tool for Intuit's workforce. So it's basically completely integrated with our LDAP and all that stuff. So it basically provides different kinds of out-of-the-box IAM roles that someone can be mapped to. So it provides like read-only access, application operations access, and power user. Now, most of these roles basically suffice for 90+% of the use cases. For the remaining, they do provide us access to be able to create custom roles, but everything is monitored, like what kind of custom role is being built out. So it has the capabilities for security monitoring, auditing, and compliance all built into it, so we don't have to kind of worry about that, just like we as a platform are providing the same to our customers. And then finally, SSH, right? None of the developers actually have their SSH keys sitting on their boxes. Everything is basically kind of works on kind of mix with the central search authority and IAM roles. So all of that is pretty well kind of integrated. Ben is going to talk more about the SSH access when we get onto the operations aspect of this. So finally, we come down to the risk analysis, right? We've done all our work, and we want to kind of figure out what kind of risk we are in based on our understanding of the system. So that's where we do the threat modeling exercise. So we have the attack vectors, which I think most of you should be familiar with. If not, it's basically kind of what are the different ways someone can basically take advantage of your system. So as an example, maybe some engineer with privileged S3 access is able to download data from S3 and give it to a bad actor. Or someone happens to get access to your EBS volumes and basically is giving the data to a bad actor. Now, you could come up with all different sort of attack vectors, but what is really the likelihood of that happening and what is the impact that it brings? And that's really kind of the second phase that we are showing here is the initial risk summary. So think about it at a high level. If you want to kind of just dumb it down, it's your impact of a low, medium, high, and your basically what you call the rate of happening of low, medium, high. So you have a 3x3 matrix, and then you kind of map it up to see what's the probability of something happening and how risky it is. Then you go ahead and say, okay, what are the mitigation controls I can put in place that will basically reduce some of this, right? So you might say, okay, I'm going to use Olympus tool, which is our internal tool to kind of do this, which means that everyone has to go through kind of temporary credentials and stuff. I'm going to give the least minimal privilege to everybody. And some of these attack vectors might actually come down in the spectrum, and something which might be high might go down to a medium or a low, which basically comes back to the next stage, which is the residual risk summary. After you have applied the mitigation controls, where does your risk summary now lie? And based on that, if you've kind of applied all the mitigation controls that you can, then there are always things that can go wrong. So you want to make sure that you have a playbook in place based on, you can kind of don't have to do everything at once, but kind of follow like a crawl, walk, run phase where anything which is high impact or high probability that could happen, make sure you have a playbook in the crawl phase for it. And then maybe something in the medium range goes in the walk and then finally run. And one of the critical things that we need to keep into account is this is not a one-time thing when you go into the cloud, right? This is something that has to be baked in your OpMech, right? It has to be something like you do functional testing and you do performance testing. Security testing and threat modeling is very similar. Your software is not standing still, so should your security should move along with it. So we have basically teams at Intuit that are actually building some of the threat modeling as tools that we can integrate into our CI/CD pipeline. So it's not something that comes in like, oh, you have to go do this. It's just basically baked in. The next part is, okay, you've done everything that you can think of as an engineer, right? Awesome. You've followed all the best practices. You've gone to all the security seminars that you can, and you figured out everything that you need to do. But then there is this set of people who basically day in and day out just do security, right? And we want to leverage them. We happen to be lucky that we have a dedicated security team at Intuit that basically helps us with all this. So you want to be able to figure out, okay, what things that I have not thought about can something go wrong with, right? So there are like two categories of testing. It's basically external testing and internal testing. So the external testing is basically what can someone do to the assets that are visible on the internet. And then internal testing is basically what if someone happened to get past your firewall and let's assume as an example, come on your EC2 instance. What kind of damage can they do from there? So you could find interesting things basically in this, right? You could find that you're using like a third-party software that you've not changed the default credentials for. You might not think about it because you're just thinking about your application, but depending on what the third-party software does, that could be a pretty big kind of attack surface. Or like all of us know that never run your service as root, but how many times does it come naturally like the first thing that we think about? Or basically that if someone gets onto your EC2 instance, all of us pride that we have the best policies that we've written and clamp down the policies, but you might find that someone can do things on your S3 bucket that you've not thought about because your policy is not as strict as you thought you had written it to be. So you could find things, right? They could all be in different spectrums, basically. So who can do this? We have our internal security team, right? If you have a security team as well, awesome. Sometimes I've seen this is actually a collaboration between an internal security team as well as an external vendor. So things like that could happen as well. So I'm going to hand it over to Ben to talk about the operations aspect.
All right. Well, with respect to operations in general, we are always working toward more continuous pipelines and deployments. The more automation we can wrap around our system, the better. The fewer opportunities for human error to be injected into the system, the better. And we're trying to get to commit to production within hours kind of a cycle here. But we do occasionally have to pull back and make sure that our enthusiasm for automation and speed does not outpace our ability to keep things secure. Priority 0 at Intuit is the protection of customer data. And that extends throughout the software development lifecycle. Intuit has taken on a number of secure SDLC tools, which are in use now company-wide because they are integrated directly into the build platforms we all use. Some of these relatively frictionless tools scan our code for problems there. Some of them take a look at unspooling all of our dependencies and noting any deprecated libraries or known vulnerabilities there. Some of them are agents that ride along with the JVM through integration testing and follow the flow of data and look for problems there. We also keep security in mind during our deployments. We use Terraform to orchestrate all of our AWS resources, and Terraform runs from a Jenkins box in a dedicated infrastructure account. We give it cross-account access with temporary assume role credentials during a deployment, and we do regular audits of the role that's assumed in the target accounts to make sure that there are no extraneous permissions, nothing beyond what it needs. We have different Jenkins boxes also in use for deploying into different accounts, so they're siloed that way, and that gives us another way to significantly reduce the blast radius of any potential bad actor that gets access to one of those machines. One other aspect to life at Intuit is a core team that maintains a catalog of images, AMIs, and they have the tools to scan every account under their purview for any deprecated images that you happen to be running. And they mandate that every 30 days you need to be restacking. And if they find something older than 30 days, you will be hearing about it. It can be painful to have to restack everything under the sun on a monthly basis, but it's important to establish that regular cadence, because while not every monthly update from this core team necessarily contains an OS with a security fix of some sort, if you are well practiced in your restacking operations, then the next time there is a meltdown or a specter, then they don't need to run around the company for 6 months chasing down individuals and asking them to take care of their stuff. Finally, we also have hundreds of SSL certs and encryption keys in our ecosystem, and many of them are already being rotated on a regular basis by automation, and the ones that aren't are immediate candidates for some more nifty automation, because who wants to be doing that manually? All the automation brings me then to monitoring, because someone needs to let us know when we're doing things wrong. Intuit has a central Splunk server that collects not only our application logs, but also Bastion logs. Everyone who uses Olympus, which Amit mentioned a minute ago, to SSH into one of these hosts, they're authenticated by a central cert authority, and then their name is in those logs, which are then forwarded onto the central Splunk service and analyzed. The agent that forwards those log events and other security events is baked right into the baseline images by the other team I mentioned earlier. So there's really no escape. Everything in our accounts is monitored by Intuit's policy engine, which is a fork and a framework of Capital One's Cloud Custodian. So it's a huge series of AWS Lambdas, CloudWatch events, AWS config rules, that have some cross-account access built in. And they alert on and can optionally mitigate violations immediately as they appear. Like, for example, public S3 buckets, security groups with wide open inbound rules, or even just unauthorized citers. IAM users with permanent access keys. Any of those are going to be obliterated the moment they appear. And then you'll get a notification. Probably multiple per day, and you'll be embarrassed. So as mentioned on the previous slide, all of our dependencies, all of our code, everything is scanned by the CI/CD pipelines, and everyone at the company has got their eyes on one dashboard or another. So if the constant notifications don't do you in, then you will eventually hear from a director or a vice president who's very keen to know why you have not restacked your Bastion nodes. Okay, so I will hand it back to Amit.
Cool, thanks, man. So in summary, I think we wanted to share some lessons learned with all of you. So the key lessons learned basically was, like we started off with, identify the biggest blockers to adoption and address them first, right? We want to kind of sometimes tend to say, oh, let's do the easy stuff, gives us some confidence, but I think just make sure that you kind of head on and address some of the biggest blockers. Identify and plan for the long poles. There are things like data migration, which might not always be very technically challenging, but it takes a long time. So make sure that you plan for it and you don't have to rush, causing various issues for you. And then make sure that security-related testing, monitoring, and alerting is never an afterthought. It's baked in just like you have your functional and your performance, right? If you have something wrong in your application, you want to get known. If your performance SLAs are going off, you have alerts in it. Why wouldn't you do the same thing for security? So make sure that that's baked in. It should not be a one-time thing. Make sure it's part of your process. And then finally, business continuity planning, right? We've all been in software long enough that whatever can go wrong will go wrong. So make sure you plan for it. Hopefully you never have to use it. So make sure you kind of practice before and hope that you never have to execute on it. And then prepare your team, right? Functioning in the cloud is much different, right? You need to have training. The DevOps mentality is kind of really accelerated. So you want to make sure that your team is sufficiently trained. You don't want to have like one or two people who all know everything else and everyone else is just a pure software engineer. So make sure like you have that good mix. Prepare them so that you as a team are successful in delivering your project. And then learn and optimize along the way, right? Don't bite off more than what you can chew. There are things that can be done later. I know we all want everything done, but treat this as a marathon. It's not a sprint, right? So make sure that you kind of have the right milestones along the way. And then if there are three key takeaways that I and Ben and I would want you to take from this session is basically security strategies ever evolving. So make sure that it's not a one-time thing that you go to the cloud. You want to keep making sure that it's you take a look at it. Hopefully, if you have the tools to do that, that's even better. So you don't have to kind of put a reminder on the calendar that every 3 months you want to do something about it. It's just kind of it becomes a best practice. And then automate. I don't think Ben and I can actually say enough about it. It will basically pay dividends in the long run once you spend the time on early automation. It might slow you down in the beginning, but it's just awesome when you have automation in place. And then finally, leverage your partnership with AWS. They have multiple resources, not just kind of support. They have AWS ProServe, they have blogs, they have videos. They have a lot of good stuff on the internet that you can kind of learn from. So make sure you learn from them, and hopefully you make less mistakes along the way, and you're successful in your journey to the cloud. That's it. Thank you so much, and thank you.